In lesson 2.5, we are finding asymptotes of rational functions and graphing them. We're also going to start by reviewing long division and synthetic division because it'll be used to find oblique and slant asymptotes. If we look at example 1, we've got this polynomial divided by another polynomial, and we're going to start with long division. So we've got x minus 4 on the outside, and then we've got 4x squared minus 3x plus 6 on the inside. And you want to focus on your first term when you divide. So we're going to have 4x squared divided by x, and that'll give you 4x. Then you take that number, that term, times everything on the outside. So you're going to have 4x squared and negative 16x. You put parentheses around it and subtract because you are subtracting both of them. You're not just subtracting the first one. So we've got 4x squared minus 4x squared, which makes 0. And then we have negative 3x plus 16x. So that's going to be 13x. And then we bring down the next number. And then we divide again. So we're going to have 13x divided by x, which is 13. Then we take that number multiplied by everything on the outside. So that's going to give me 13x and negative 52. And we put parentheses around it, and we're going to subtract. So we have 13x minus 13x, which cancels, and then we have 6 minus negative 52, which means we're going to add 52, and we get remainder 58. So the answer is 4x plus 13, and remainder 58 over x minus 4. Now, synthetic division is faster and a good way to see if we got that right. With synthetic, you got to set what you're dividing by equal to 0. So you would add 4 to the other side, and you would get 4. And then the numbers on the top row are your coefficients for your terms. So we've got 4, negative 3, and 6. You bring down the 4. You multiply by the outside. Add your column together. Multiply by the outside. And then add your column together. And that last number is your remainder. And so you can see we get the same thing that we got using long division. Here we've got a polynomial which is missing several terms divided by a polynomial that is also missing some terms. So you got to make sure that you have all your placeholders there. So when it says x squared minus 1, you need to write x squared plus 0x minus 1. And then for this x to the 4th, you're going to have x to the 4th, and then 0x cubed, 0x squared, 0x, and a negative 1. And so now that we have all of our placeholders there with zeros, we're going to start by dividing the first terms. So we've got x to the 4th divided by x squared, which is x squared. Then we take that term times everything on the outside. So we have x squared times x squared is x to the 4th. X squared times 0x is 0x cubed. And x squared times negative 1 is negative 1x squared. Put parentheses around it and subtract. So your x to the 4th cancels. Your x cubed cancels. And then you've got 0x squared minus negative x squared. So you're going to have plus x squared. And then because there are 3 terms here, you want to have 3 terms next. So we bring down both of the next 2 terms. It's got to match what you're dividing by. Normally we just bring down 1, but here we have to bring down 2. So we have a 3 and a 3. If you divide the first 2, we've got x squared divided by x squared, which is 1. And then you take 1, multiply it by everything on the outside. So you're going to have x squared, 0x minus 1, put parentheses around it. And then when you subtract, your x squareds cancel, your 0x's cancel, negative 1 plus 1 is 0. And so you get remainder 0. which means your answer is just x squared plus 1. So let's look at that using synthetic division. We need to set what we're dividing by equal to 0. So if we go up here and set this equal to 0, we would add 1 to the other side and have to take the square root, which means we get plus or minus 1. So we're going to have to do synthetic twice, with a positive 1 and with a negative 1. So let's start with positive 1. And then just like here where you added zeros for your terms to keep your placeholder, you have to do the same thing with synthetic. So it's going to be 1, 0, 0, 0, negative 1. You bring down your first number, you multiply by the outside, add your column together, multiply by the outside, add your column together, multiply by the outside, add your column, multiply, and we're getting remainder 0. Then I know negative 1 is going to come out 2, so we're going to take out negative 1. Again, that's because of this up here. And you start by bringing down your 1, multiplying, add your column, multiply, add your column, multiply, you get remainder 0 again. And you can see that we get the same answer that we got before, an x squared and a 1, an x squared plus 1. So that's just a little review of dividing. Now let's look at rational functions. So rational functions are functions where you have a polynomial divided by another polynomial. Here are some examples of rational functions. So pretty much if you have x in the denominator, then it's considered a rational function. The graph sometimes approaches an invisible line that it'll never touch, and this is called an asymptote. And that's whenever the denominator ends up equaling 0. So since there's x down here, there's several times where the denominator equals 0, and they'll give you a vertical asymptote. So we've been talking about finding vertical asymptotes. A vertical asymptote is where the graph is going to do something like this. But there's also horizontal asymptotes, which we haven't been looking for yet. And we're going to talk about how to find those. But a horizontal asymptote, you're going to have an asymptote going through your y-axis. And it'll look something like that. And then there's something we haven't looked at either, which is an oblique asymptote, which is sometimes called a slant asymptote, which your curve is going to approach at a slant. So something like that. So let's talk about vertical asymptotes, which we have discussed before. So vertical asymptotes is when the denominator equals 0. So, and you'll always write your answer as a line. So like x equals some number is your vertical asymptote. So we're going to look for vertical asymptotes in the first set of examples here. So here we're just looking for vertical asymptotes. So we're just going through and setting the bottom equal to 0. Sorry. So here we're going to have subtract 2 to the other side. And so I've got a vertical asymptote at x equals negative 2 if you just subtract 2 to the other side. Here, if I set this equal to 0, you can either factor it or you can add 25 and take the square root. Factoring is sometimes better because you don't forget about your plus or minus when you take your square root. Here you can see that you're getting 2 vertical asymptotes. You're getting x equals negative 5. That'll make 0. And you're getting x equals positive 5. That'll also make 0 on the bottom. Here, if we set this equal to 0, it doesn't factor because it's not a difference. So let's subtract 9, take the square root. Here we're getting plus or minus 3i. It has to be real to be an asymptote, so there's no asymptote here. No asymptote. This one, let's factor. We're looking for numbers that multiply to make the outside, so we have a 1 times 10. We're looking for numbers that multiply to make 10, negative 10, and add up to 3. So that would be 5 and negative 2. 5 times negative 2 will multiply to make negative 10 on the outside and add up to positive 3 on the inside. And then if you set these factors equal to 0, you're getting -5 and +2 for your vertical asymptotes. This one will factor as well. So you want to multiply the first times the last. 1 times -21 is -21. So we want to multiply to make -21, but add up to 4. And that would be 7 and -3. +7 and -3. Multiply to make -21, but add up to 4. And then you set these equal to 0. And so these are your vertical asymptotes. So we've seen that before. Let's look at how to find horizontal asymptotes. So you've got these different cases, and we're talking about a function where you've got an x on top. So I'm going to write that as ax to the n, and an x on the bottom. We're going to call that bx to the m. A and b are numbers, and n and m are exponents, and then you've got an x on top and an x on bottom. So let's say the top exponent is smaller than the bottom exponent. In other words, if n is less than m, if the top is smaller than the bottom, then you're going to have a horizontal asymptote. And that's going to be at y equals 0. So if the top is smaller than the bottom, you can write top and bottom if you don't like n and m, it's up to you, then you're going to get 0 automatically. Let's say the top equals the bottom if n equals m, or top equals bottom if you want to write it that way. If that happens, then it's just the numbers in front. A over b is your asymptote. So y equals a divided by b would be your horizontal asymptote. And then your third case is if the top is bigger than the bottom. If the top is larger than the bottom, then you're going to have an oblique asymptote. And so that is going to, you're going to have to find that one. It's not as easy as these two. And what you'll do is you'll take the top equation and divide by the bottom equation. And then note if the top minus the bottom, or you can say n minus m, is more than 1 difference, then there's not going to be a horizontal or oblique asymptote. You're just not going to have one. So let's look at these. So here my top degree is 0 and my bottom degree is 1. So here the top is less than the bottom. And that means the horizontal asymptote is at y equals 0. If we look at these degrees, squared and squared, the n and the m are equal. The top equals the bottom. And so if that's the case, then it's your leading coefficients, and there are 1s in front of these x's. So y equals 1 is your horizontal asymptote. Here, the top is larger than the bottom. So the top is bigger than the bottom, but too big. They're more than 1 apart. So that's this case right here. If you do 4 minus 2, you get something more than 1. So there are none. And that is because 4 minus 2 is 2, and it needs to be only 1 apart. Here my top degree is 1, my bottom degree is 3, so the top is smaller than the bottom, and that means I've got a horizontal asymptote at 0. Here the top degree is 1, the bottom degree is 2. Again, the top is smaller than the bottom, so we've got a horizontal asymptote at 0. Here the top degree is 1, the bottom degree is 1. They are the same. Top equals the bottom. So that means it's the leading coefficients in front of those largest x values. So we've got y equals 3 over 2 is our horizontal asymptote. Here I've got the top is larger than the bottom, and they're only 1 apart. So that means we have an oblique asymptote. To find your oblique asymptote, you want to use long division. So you're going to have x plus 5 on the outside, and then x squared minus 8x plus 12 on the inside. And you only need 2 terms. So if I divide x squared by x, I get x. I multiply x by everything on the outside,